Hello everyone, welcome back. So in this video, we are going to understand another question in the daily contest series, right? The question is a new game 21. Okay, so this is a game. So the game setup is a little uh, easy, right? But you have to understand what the question is saying that. Okay, very first, just think that there is a person, Alice, right? Or Alice, you can say, start with 0 points, right? He can start at 0 points. Okay, so this is a game where she follow the game like the game is based on card 21, right? This is a card problem, right? So what is saying that the Alice starts at 0 points, right? And she draws numbers. Okay, so whenever she draw the number, she has how many points? Less than k points. Means until she has the less than k points, she used to draw the numbers. So each time she draws a number, a random number between 1 to max. You can see the number is between 1 to max. It's an inclusive, either 1 or the max point or between that. Okay, she stops drawing number once her score reaches to k or more points. Okay, this is the very easy things we have given. Now it is saying that you have to return the probability, right? The question saying that what is the probability that Alice final score is less than equal to n points. Understand? Her score should be less than equal to n. Understand? And this is the accepted answer for the LeetCode problem. Okay, so if you see an example here we have given. So let's take this example. This is easy. Okay, so if you observe example 2, where n is given 6, k is given 1, and max point is 10. Okay, so can we say when in a step 1, what Alice needs to do? Alice starts at, now let's suppose call at 0, right? Where she starts, right? So we know that she starts with the 0 points, means initially the score is how much? 0. Next, understand when she uh, draw the numbers, right? Since we can say since k we have given is 1, right? What we have given? K we have given is 1. So she will stop as soon as she draw anything, right? Whenever she want to draw, right? Draw anything. Oh, Alice. Whenever she draw anything, right? So she will stop as soon as she draw anything because this k is equal to 1. Okay. So what is the possible draw? Understand? Max point we have given. So possible draw is between 1 to 10. 3, 4, 5, 6, 7, 8, 9, and 10. These are the possible draws. Can we say that? What is this? The possible draw. She can get any of these, right? So all are equally likely, probability 0.1. Can we say that? Like means if you find the probability, what is the probability? 1 by 10, right? Means it will become 0.1 for each. I am talking about the probability, right? What is the possibility? Probability. So all are equally likely, like 1 by 10. Either you get 1, 2, 3, 4, 5. The chances are if she pick any of these, right? It means the possibility of each point if we get from here is 0.1 each, right? So can I say the final, so you can say the final score which is possible, which is possible, right? I'm not saying the perfect one. Okay, the final score will be what? Think it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any of this be possible. Can we say that? The final score can be anything possible. Now, just think that, okay, now just think that, let's suppose in step 3, we have to count. where we can say count is less than equal to n. Here n we have given is 6, correct? So what is the valid score? So the valid score we can say is between what? 1, 2, 3, 4, 5 and 6. This is the valid score. This is the valid score, right? And so if it is a valid score, total how many outcomes are there? 6 outcome. Can we say that? What is the invalid score? We can say 7, 8, 9 and 10. These are invalid score. Can we say that? So we can say how many invalid score are possible? 4 invalid outcomes are possible, right? It means if you want to find the probability, it will become how? 6 by 10 is equal to 0.6. Understand? And this is the answer we have given if you see here. I hope you are understanding. Okay. So this is the problem statement we have given. Very first, we know that allies start at score 0, right? Since k we have given is 1, so C can draw any number. Which is the possible draws are between 1 to 10. So what is the probability for each is 0.1. The final score which is possible is from 1 to 10, right? So if count we have given is less than equal to n, right? We have to count, right? So count if it is less than equal to n means n equal to 6 we have given, right? So the valid score that we can get from here is 1 to 6. The total 6 outcome is possible for the valid cases, right? When we talk about the invalid cases, we have 4 cases are there, means 4 outcome will be possible. If you find the probability is the valid one, right, by 10, you will get about 0.6. So this is our valid possibilities. Okay, I hope you are able to understand. If you have any doubt, just ping me a message in the Slack, not Slack, sorry, in the comment section. I'll help you there. So let's understand the intuition. Very first, let's understand there is a number line view. Okay, so imagine there is a Alice, right? She wants to start from where? At 0. Let's suppose this is your 0. Okay, take a line. Okay, this is 0, then we have 1, then we have 2, then we have 3, then we have 4, 0, 4 and so on till n. So if this is a number line, okay, if this is a number line, so Alice is at where? At 0. Okay, this is your Alice. Okay, she is standing on at line 0, right? So for each move, she jump forward by a random steps. Either she is taking this step, this step, this step, this step. These are the possible number of steps we can say. Can we say that? She can jump from here to any of this number, right? That is your random steps we can say. So when she jumps forward by a random steps, what is the possibility? Possibility is that she can go from 1 to max point, right? This is the possibility that this is her range from 1 to max point that we have given the question, right? If the max point having the range from 1 to max, any of these jumps can be in the random steps. The jumps will be in the random step, you can say. Okay, by random steps we can say. So all steps are equally likely. Either he can take those. So we have seen the likely steps means if we are talking about the 10, 1 to 10, the possibilities are 0.1, right? That we have seen. So all these steps are equally likely. When she stops, when she reaches to, let's suppose k or more, right, points, then she has to stops, right? When she stops, when it reaches to the k, that k we have given for each of the example, right? So whenever she reaches to k or more points, right, she needs to stop it, right? So what we really care about, let me clean it. Okay, so what I'm saying, uh what we need to care, right? What we really care about, like we only care about the final resting place, right? If the final score is between what, between final score between k to n, right? This is our success case. If the final score, if the final score is in the range k to n, so this is our success steps. Can we say that? If the final score is between n plus 1 and 2 k plus max point minus 1, let's suppose, it means this is our failed step, right? So essentially alias ends in the band of max point, right? When the band of length max point is coming here, right, then c stops, right? It means c stops somewhere between this point, or you can say k, if you take from here, k minus k plus max point minus 1. So this is the range where somewhere c stops, because the points can go more than the max point, right? So we should only care about if it is less than equal to the k, right? The max point should not increase, right? So c will stop here, right? So probability is that when we understand the probability, right, we have to think about, let's call a dp, right? So dp is a bucket of probability sitting at a position I. Okay, we can tell you how. Here you think, so you understand the dp, right? So dp at I, if we consider this as a bucket of probability, right? Bucket of probability. So if this is a bucket of probability which is sitting at position where, at I, right? So when we start, right, so we'll say dp at 0 is a start, and its probability is initially what, 1.0 will take. So all the probability will mass at where, at 0 is 1. Can we say initially, right? So from position 0, right, we have seen Alice split her probability event, right? It means it will go for all equally, right? From here to, if you talk about from here to here, from here to here, the probability of the view is equally or evenly, we can say, to the next max point that we have seen, right? So the point can be from 0, it will go to where, between 1 to max point, right? And each will get the probability 1 by max point. This is the probability. So from each new position, right, which is less than k, she split the probability forward again, right? She will do that again, right? So from any position which is let's suppose between, if any position which is less greater than equal to k, she will stop. That we have seen, right? So the very first will go from k minus n, right, and then we'll go to here. So for each position, when her new position is less than k, let me show you how. You understand this part, right? Let me clean it. I will remove this part, cleaning part. Okay, sorry. So let's suppose for any, this is a new position. There is a new position. Can we say that? So whenever we get a new position, and if it is less than k, means she trying to spread the probability in which direction? Forward direction, right? For any new position, if it is greater than equal to k, means she has to stop, right? In this case, she will keep moving ahead. She will spread it going forward, right? And whenever she get greater than equal to k, she has to stop. Means the probability stays here, right? Can we say that? If you understand till now, means you also have to understand the approach that we are getting from here is sliding window intuition. right? So if we understand the sliding window approach, right? So to compute the probability, right, at let's suppose at position I, we only need the average of the previous max point, right? That we have the probability that will store, right? Let's suppose, can we say this dp at I is nothing but, it's a linear, that is why I'm saying it's a linear, right? So we'll say dp at I minus 2 plus dp at I minus 3, like that we can say. Can we say that? And we'll divide by 3. If we have max point is 3. If max point is 3, can we say that dp at I minus 1, dp at I minus 2, and dp at I minus 3? This is a linear probability, okay? So if the max point is 3, we'll divide by 3, right? Because we need the average of previous max point probability. So we know that the max 3 probabilities are dp at I minus 1, dp at I minus 2, and dp I minus 3 for dpi. So if we want to compute the probability at position I, we need average of 3 previous max point of the probabilities, right? And that we can get from here. Can we say that? We can say that, right? Because this is a linear probability, right? Okay. So instead of recomputing each time, we'll keep a sliding window sum of the last max point, right? So we don't need to calculate again. Okay. Let me tell you how. So let's understand a small case. Okay. Let's suppose we talk about the example. Let's take a very simple example. N equal to 6 we have. K equal to 3 we have. And the max point we have is 2. Okay. So if we represent in the number line, we'll say 1, 2, 3, 4, 5, and 6. Can we say that? We can say that, right? We know that very first we'll start at where? dp at 0, and it is 1.0, right? Means 1. When we start at from 0, it will spread to, let's suppose it will start at where and spread it to 1, 2, which is equally, we can say, is 0.5 each, right? Can we say that the probability? So if we start at 0 and we split to 1 or 2, means either will go to 1 or 2, the probability for them is equally 0.5 each, right? So can we say dp at 1 is 0.5, dp at 2 is 0.5? We can say that, right? So from each point, let's suppose if we'll reach to now 1, right? Since k is 1 is less than k, means is spread to what? It will go to 2 or 3, as we have came from here to here or here, right? So we can say that. So as we start from 0 to 1 or 0 to 2, right? We have seen the probability 0.5. Since now we are, let's suppose, at 1, the probability of from here 1 to, we can go 1 2, or we can go to 3. Can we say that? Means from 1, the probability, since k is less than equal to, this time 1 is less than k, right? So it's split to 2 and 3. Can we say that? So in this case, dp at, let me clean here, right? You know that this, right, it is 1 is less than this. So in this case, dp at 2 we have seen is 3. Now dp at 3 is become how many? It will be updated, right? So let's say plus will add 0.25. Here think about dp at 3. It will become what? Plus 0.25. It will get added. So each time if will get added, right? Let's suppose we'll reach to the 2. From 2, from 2, what is 2 is less than k, correct? So if 2 is less than k, means we need to split from where? From 2 to 3, then we can go to the 4, right here. Okay, so the chances of, give me 1 second. So similarly, if we'll say, let me tell you how. So we have seen that 2 is less than k. It means we will update dp at 3 plus equal to 0.25. Similarly, dp at 4, it will become what? We'll say plus 0.25. So like that, we'll keep moving ahead. We'll find from 3 to 3 plus, and whenever it will go to 3, we know that it will reach to what? 3 plus 3 plus. When 3 plus happen, so it will stop, right? Here it will stop. No more talking, okay? Okay, so the final valid start at where? From 3, 4 and 5 and 6. So whenever we see this case, right, we have seen that now k is the value, the score is becoming more, right? Means k to the last we are reaching, right? So the valid state will say 3, 4, 5 and 6. These are the valid score now, valid states you can say for this case, right? But the probability sits at 3 and 4, 3 and 4 we can say. So we can say dp at 3 and dp at 4, right? So it will become what? 0.5, and for this one 0.25 itself. So if you add total 0.25, right? So if you add these two, how many will you get? 0.75. So this is the probability that we can get from here. So the big in a picture of this intuition is a lies probability is likely water flowing across the number line, right? Can we say that? So at each step, water at I split evenly into the next max point bucket, and once it reaches to the k, the water stops flowing. So we just add how much water flow lands between this k to n. Can we say that? We can say that. And this is why the sliding window approach will work. So we'll say sliding window average will work, right? So for each position, probability is just the average of the new average of the previous max point water level, right? That we have seen. Now understand, as we know that k is, if k is what we have given n, k and points we have given. Very first we'll check if the boundary condition match, will return 1.0. okay, so these are your conditions. Okay, then we have the dp. You will create a dp array, and initially you will update the start points at 1.0. you have the current window is 1.0. the we can say the sum of the probability for the last max point, because we have to find the max score, we have to find, right? And we have to take what? Double in the result. Very first we'll start from 1 and you'll go to the last point, right? So each time you have to find the average, the window and the max point you will define, right? You know, you need the sliding window average, right? For that we have to divide it, right? So whenever I is less than k, we know that we just need to keep drawing, right? We have to increase our max point score, you can say. Whenever we reach to the you can say more than max point, right? If it is greater than this, right, it means we have to stop it. We don't need to do anything, right? At this point you will do what? I minus max point. If it is greater than equal to 0, means we have our window. Let's update our window. We will update it. Okay, and finally you will return the result. So this is a pretty simple problem, right? But still, if you have any doubt, let me know in the comment section, right? I'll try to give the answer. Okay, thank you guys, thank you for watching this video. I'll see you in the next one. Bye bye.